Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 5, Section 6, Direct and Inverse Variation. So starting with a couple definitions. Direct variation. It's when the relationship between x and y, when one of them increases, the other one increases. So an increase in x causes a proportional increase in y. And since it's proportional, this is one of the reasons we study proportions so much. Now it's going to pay off. Inverse variation is different. It's when one of them is increasing and the other one decreases. So let's talk about this in real life, a real life example. Let's see, for direct variation, there's so many. For example, the more people I invite to dinner, then the more food I'm going to have to prepare to feed them. As the number of people goes up, the number of placings at the table goes up, the more food. And likewise, if one comes down, the other comes down. So direct variation is proportional. Now, inverse variation is proportional in a different way. When one of them goes up, the other comes down. Let's see, for instance, if we had the task of painting some houses for elderly people in our church, the more people I would get to help with this project, the less time it would take to complete the project. So in this example, when the number of people goes up, the time that it takes goes down. So this example is inversely proportional. So direct and inverse. When we work with these, you can see right here we have some formulas. We need to know what that letter K is. K is the constant of variation. It's the factor that is in the proportion. And I don't know why mathematicians call it K, because constant starts with the letter C, but we don't use C, we use K. I don't know. Your guess is as good as mine. But just please note, K is not 0, otherwise we wouldn't have a proportion and we wouldn't have any real life problem to talk about. If I didn't invite any people and I wasn't even there to eat, I'm not going to prepare any food. So the zeros just don't help us. So now we have these formulas that help us when we're going to differentiate between direct and inverse in the different problems. So direct, y equals k times x. The k is the factor that you're multiplying by, and it's the same as the proportions that we dealt with before. In any direct proportion, it's, y is to x, y1 is to x1 is y2 is to x2. So this is normal. This is like the ones you've always done. But we need to contrast that with inverse proportion. Now, inverse proportion, the way I remember it is you're dividing by the x. Y is the constant divided by the x. And this we'll look at here in a minute. I'm just going to point it out to you that any xy in an inverse is equal to any other xy, meaning multiplying. And like I said, we'll talk about that in a minute, and hopefully that'll make more sense. The first type of problem we'll be dealing with is to look at these various equations from 1 to 5, and we have to state whether they represent a direct relationship, an inverse relationship, or neither. So please don't think that, like number 2 has a fraction in it, 3 has a fraction in it, 4 has a fraction in it. Those all must be inverse. That is not at all how it works. So let's take a look at these. So just to make it clear in these examples, the r is the same as the y, and the t is the same as the x. So I just wanted to make that clear. So now let's take a look at number 1. If r equals 20 times t, that lines up perfectly with direct. It really couldn't be easier. So that's a direct relationship. Now looking at number 2, again, it is pretty straightforward. It's just like y equals k over x, r equals 20 over t. So this is definitely an inverse proportion. Now again, we might think that 3 is an inverse proportion, but let me just point something out to you. This isn't dividing by the t. And another way that it's possible for me to write this is, instead of dividing by 20, that's the same as multiplying by 1 over 20 times t. And so in this case, the k is a fraction. It's 1 over 20, but it's still just a number. So because of that, this is definitely a direct. So number 4, I can't tell by looking at it because the letters are, in the fraction. So let's solve for the r, and then we'll be able to distinguish. So if you recall, back when we did literal equations, we learned a strategy for getting the r out of the denominator. And what we learned is that we needed to multiply both sides by r so that they cancel. So then I get t equals 20r. But I haven't solved for the y yet, or in this case the r, so we need to divide both sides by 20, and then I can see I have t over 20 equals r. And this is exactly like number 3. The dividing by 20 can be written as the 1/20th fraction, which is just the k, so this represents a direct. Here in number 5, I need to solve for the r, so divide both sides by t, and I get r is 20 over t, which is definitely an inverse proportion. The next type of problem you'll be asked to do is to find the k, find the constant of variation. And once again, when we read what type of problem this is a direct. The first thing I write down is the equation or the formula to remind me what direct proportions look like, y equals k over x. So we need to find this k. Then we can plug in, for the x, we can put in the 6. For the y, we can put in the 18. And I'd have 18 equals k times 6. You are an algebra student. You can very quickly solve for k and get k equals 3. But now we're only halfway done. Now they want us to write the function rule. So we take our k and we put it in here. Now a function rule is an equation. It has an x and a y in it. So keep the x and y. Okay, this is our first answer. Keep the x and y and just put in the 3 to stand for this particular direct proportion using this k, and now this is the function rule. Number 7 says it varies inversely. So the first thing I do is write down the inverse formula. Let's find the k. We plug in the numbers we're given. 12 equals k over 2. Multiply both sides by 2, and k is 24. Again, that's just the first answer. Now we write the function rule with the x and the y in it. So y equals 24 over x. Now, please remember that skill of finding the k, because you're going to need that in this next type of problem. We're told that y varies inversely, and we have the first part of the problem. When y is 4, x is 24. I'm just going to draw a line here. Let's stop there. So let's just do this half of the problem and use that information to find the k. And then after you find the k, then we're going to go on and do the rest of this, and we'll find the other y when x is 8. So again, inverse proportion, write down the formula, y equals k over x. Now let's find the k using these first two values. So 4 equals k over 24. If you multiply both sides by 24, we get a value of 96. Now let's take this and let's use it to do the second half of the problem. We don't know what y is. This is what we're looking for. So y equals, now put the k in, put the 96 that you found, and we're dividing by 8. And I believe 96, I believe that is 12. Check my math. That's the final answer to this problem. So it took us 2 steps to get there. Let's approach number 9 the same way. This one is a direct. It says y varies directly to x. Y equals 16 when x is 64. So let's just stop there. Again, the strategy is to find the k first, and then we'll go on and finish the second half of the problem. So for direct, write down the y equals kx. Plug in the 16 and the 64. So 16 equals k times 64. And then if we divide both sides by 64, we're going to get a fraction. 16 over 64, which reduces very nicely. If I did this right, it reduces to 1/4. So let's now go to the second step of the problem. Let's find y when x is 40. So y equals kx. K is 1/4 in this case, and that's going to be multiplied by 40. And 1/4 times 40 is 10. So y equals 10. The next type of problem we'll be asked is to determine in these tables which one represents a direct and which one represents an inverse proportion. So we have to be careful. We have to check a couple things. So first of all, we know that in inverse, as the x is coming up, the y is coming down. And in direct, if x is going up, y is going up. So just knowing that basic, we have a suspicion here. We see that x is getting bigger as y is getting smaller. So we suspect this one could be inverse, but we need to confirm that. I rewrote this here from the first screen to, remember I said I was going to clarify this. Inverse is y equals k over x, but this is the part that's really interesting about inverse proportion. Any x times y equals any other x times y. All of them have to follow this formula, this rule. So if we looked at x times y in this table, 1 times 12 is 12. Another x times y, 2 times 6, also 12. Any other xy, 3 times 4, 12. 4 times 3, 12, 12. So since all the xy's equal all the other xy's, we can definitely say yes, this is an inverse proportion. Now this table we suspect is direct because as x is going up, y is going up. But we need to check further and look at the k. Is there a factor that's being multiplied by every single x to get the y that goes with it? So we look, what are we doing here? 1 to get 3, 2 to get, well, there it is. We're multiplying by 3. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3, and so on. So because of that k, we can say yes, definitely, this is a direct proportion. The last part to look at here is the graphs. I've given you 3 graphs, and one of them is direct, one of them is inverse, and one of them is neither. So take a minute and see if you can tell. So I guess the inverse could maybe be the easiest one because remember, as the x is going up, the y is coming down. So in this graph, x is getting bigger and y is getting smaller. So this is definitely the inverse graph. Now, of these two that are left, one is direct and one is neither. So let me just remind you, in direct proportion, y equals k over x. So if you look carefully, the only difference, really, they're both positive slope graphs, so as x is increasing, so is y. This one, however, does not start at 0, 0, and this one does. Looking at our formula, if x is 0 in this case, no matter what k could be anything, but if x is 0, so is y. So the ordered pair 0, 0 has to be the start of a direct graph. Therefore, this one is the direct and this one is neither. All right, now you have all the information you need for section 5.6, so have fun with math.